Good evening, everyone. We are in the week 5 problem solving session of the NPTEL course Network Analysis, and week 5 is about self and mutual inductance of a coil. I am Teja Golla, a fourth year research scholar working under Dr. Santanu Kapat at Embedded Power Management Lab, EE Department, IIT Kharagpur. So let me share my screen. Can you see my screen?
Yes, sir.
Okay, so you can share the picture so that I can copy paste that picture here and we can discuss before we go into week 5.
Sir, it is a assignment question of week 4 this
Okay,
year.
because I am not accessing the assignment. If you can share the screenshot, that would be good because this year assignments I have not downloaded.
Okay, sir. Wait for a minute.
Okay. So last week we have discussed which topic? Sine, right? Using phasors. Yeah. AC circuit, sorry. AC circuits using phasors. Steady state only, not transient. Okay. So Vishnu, how are you doing in your weekly assignments? Hello, Vishnu, are you there? Yes, sir, doing good. Okay. Nice. And I hope you are able to access all the materials that I'm uploading to my drive as well as the videos that I'm uploading to my YouTube channel. Okay. Yes. Okay. Okay. Can you see my screen, everyone? This question you are able to see, right?
Yes, sir.
Okay. So let me just take a screenshot and paste it on my screen so that we can write. Yes. So I'll just mention this is week 4 assignment doubt. Okay. So this is one problem similar to what exactly we have discussed in the last week. Maybe I may not have solved fully, but I have given the idea so that you will be able to solve. So this is like a week
Yes,
4
sir.
assignment doubt. Yes.
Sir, in this, I have solved the problem by taking voltage source and I
Okay.
got the voltage across 1 microfarad capacitor.
Okay.
It was 25.3 angle minus 90.
Okay.
So from there, I am getting in conversion. I am facing problems. So I could not exactly convert correctly in cos the angle of cos.
Okay. So in that case, you remember, right? So if it is sine, what? How do we convert it into phasor?
V angle minus theta.
Yes. So it will be 20 angle minus 90 degrees, right?
Yes, sir.
This will be 4 angle minus 90 degrees because I have said, say if it is minus 90 degrees, then it becomes cos of theta, right? So it will be cos of 100t minus 90 degrees. So cos of minus theta is cos theta. So I can write it as cos of 90 degrees minus 100t. So cos of 90 minus theta is sine theta. So it will get sine 100t. So now there are two things that you have to keep in mind. Once, like first of all, we are doing superposition. Say this is my source 1 and this is my source 2. So when you are doing with source 1, then omega is 100. So the inductance capacitance value will be with respect to omega equal to 100 because here it is omega 100. When you are doing with 200, then these values will change because this is j omega l and this is 1 by j omega c. So this is one thing you have to keep in mind. The inductance and capacitance in both the cases will not be safe because it is dependent on omega, and omega is different for both the sources. Now, say you are getting, what did you say? What is the VC that you are getting?
25 angle minus 90.
25 angle.
25.3.
Okay, so you have said 25.3 angle minus 90 degrees. When input you have considered 20 angle minus 90 degree.
Yes, sir. Considering voltage sources.
Okay, so let's say assuming this is correct, because I am not checking whether this is correct or wrong, but assuming that, so this is VC1 because it is because of source one. So now if I want to convert it into, because if you see in the question, it is written in cos, right? So we have to write it in terms of cos. So let us do. So if I do, then what it will be 25.3 cos theta, right? So omega t plus theta. So it will be cos of 100t minus 90 degrees, right? So if it is cos of 100t minus 90 degrees, then what is my theta? Theta is minus 90 degree, which is pi by 2, minus pi by 2, right? Agree? Hello? Do you agree?
Yes, sir.
Yes. So with respect to your answer, theta should be minus pi by 2. But because they are saying it is wrong, I am pretty sure that the value you got may not be the correct one. So can you calculate what is j omega L?
Sir, while writing the triangular trigonometric equation, we use Vm cos omega t minus of minus 90 होगा ना?
No, no, cos of C, it will be just plus only. Like if my angle is say, okay, then I'll go to my old notes so that you can see what convention we have followed. Yeah, so this is the convention that we have followed. Where is the convention? Hmm. So if it is say theta, Vm angle theta. So whatever is the angle, that will be written cos omega t plus theta. Say if my angle is theta minus 90 degrees, then what happens? It will be cos of theta minus 90, which is like cos of omega t plus theta minus 90, right? So I can write it as sine of omega t plus theta 2. So if my angle is theta 2 minus 90, whatever may be the angle, it will be added to cos of omega t plus. Say, I don't care what is the angle here, I will write cos of omega t plus that angle. So which is what we are doing. So I am not caring whether it is plus or minus. So if it is say some theta, here it is negative, I will write cos of omega t plus theta. So here it is negative, so that's why theta is minus 90. So
Okay,
this
sir.
will be 20 angle minus 90 degrees. But I am thinking if it is minus 90 degrees, here maybe you will not get minus 90 degrees. So here you will get something else that you have to check what you are getting, because here they are saying A is negative, right? So I think you have made a mistake. So this may not be the correct one. So you have to calculate what is 1 by j omega c. It will be some minus j. This will be some plus j, right?
Sir, it is minus 10J.
This is minus 10j. Okay. Can others
Yes,
calculate
sir.
and check, because I am not doing it. I am not sure. So you are saying this is minus 10j, right? And the other one?
And L is 2.1J.
J 2.1. Okay. So now what is VC1? VC1 is equal to minus J10 by 2.1 plus 10 is what? 7.9, right? Minus J 7.9 into 20 angle minus 90 degrees. Okay. So in this case, you are correct. Then if this is minus J10, can everyone calculate whether you are getting minus J10 or not? So 100 into 1 milli, I think, yeah, minus J10. So 21 milli is what? 21 into 10 to the power minus 3 into 100, 2.1. Yeah, then you are right. So in that case, it is 7.9 by 10 into 20 angle minus 90. So you are getting 25.3 angle minus 90. So then in that case, there might be a mistake that they have committed. So what you can do is you raise a question and ask saying that we are getting the other answer, not this.
Okay, sir. Thank you.
Okay. Any other questions you have? Anyone? Anyone? Okay. Okay, let me just check once the question. They have said minus pi by 2 less than theta less than or equal to pi by 2. Okay. Hmm. Okay. So, okay, I think maybe this is the logic. So, the angle that we are getting is 25.3 cos of 100t minus 90 degrees, right? Agree? So, this I can write as something like this: 25.3 cos of 360 degrees plus 100t minus 90 degrees. Everyone agree? Can we write like this? Cos of theta is
Yes,
cos
sir.
of 360 plus theta. So now this one I am writing something like this: 25.3, 270, right? So 270 I'll write cos of 180 plus 100t plus 90 degrees. This is okay, everyone?
Yes, sir.
What is cos of 180 plus theta? Minus cos
Minus
theta,
cos.
right? Okay. So 100t plus pi by 2. So I get it. Like you are not wrong, but the tricky part here is if you see they have said theta cannot be minus pi by 2, but theta can be equal to pi by 2. So the range of theta is minus pi by 2 and it is not equal, but it can be equal to pi by 2. So I can write 25.3 cos 100t minus 90 degrees as minus 25.3 cos 100t plus 90 degrees, but in the first case theta is minus pi by 2, and then they have mentioned please ensure that theta cannot be minus 90 degrees. So you have to write in a different way so that the theta will fall in the range. It's not that whatever you have obtained is wrong, but they have put a tricky thing saying that it cannot be minus 90 degrees because they know that you will directly get minus 90 degrees, and they wanted you to write in a different way so that theta will fall in the range that they have specified. So that maybe that was the tricky part here. So in that case, so they have made it so clever that both the questions are related to it. So once you miss that, both the questions are wrong, but like your process is correct and your calculations are correct, only that theta cannot be minus 90 degrees. So that's why you have to play with it so that theta will fall in that range. You got that mistake?
Yes, sir. Thank you.
Okay. So others, like, did you get it? What he was asking, and like, what was our discussion? He got 25.3 cos 100t minus 90 degrees. So according to him, A will be 25.3 and theta will be minus pi by 2. But they have said that please ensure that theta is greater than minus 90 degrees. So we have to write it in a different way. So what I have done is I have added cos like 360 plus theta equal to cos theta I have used, and then I have made sure now theta is 90 degrees, and they said theta can be 90 degrees. So that theta should be within that range. Others, are you
Perfect,
able
sir.
to follow? Amit?
Yes, sir. Yes, sir. Yes,
Okay,
sir.
got it.
Same.
Okay? You are not audible. Yeah, same expression, just in a different way. So like that is the tricky part. Yeah, this is a very tricky thing because even I have not noticed that there is not equal to at the beginning, but it's tricky. Please repeat. So, Parvatam, what he was asking is, so he was solving this using superposition theorem. So in the superposition theorem he first used this, so we have converted it into phasor using the convention that we have discussed last week, and then current part he did not ask, so we were only bothered about the voltage source. So when the voltage source is connected, vc is nothing but minus J10 because it is minus J10 and this is J2.1. So using that potential divider formula, we got that VC1 is 25.3 cos 100t minus 90 degrees. So according to this, he has substituted A to be 25.3 and theta to be minus 90 degrees, which is minus pi by 2. And he is not wrong. But in the question, they have mentioned that theta cannot be minus 90. So we are getting minus 90, so we have to change it. So you have to play with the trigonometric identities to make sure that this angle is within the range that they have mentioned in the question. So I have used cos theta equal to cos 360 plus theta, and then 360 minus 90 is 270. I have written it as 180 plus 90 because both are same. Then I got minus 25.3 cos 100t plus pi by 2. If you see from here and here, here theta is minus 90 and it cannot be minus 90 because they have mentioned, but theta can be 90 because they have mentioned that theta is less than or equal to 90. So in this case versus this case, both are same, only we have just played with the trigonometric identity to make sure that theta is falling within the range they have specified. But unfortunately, in both the cases, A is different. Here it is 25.3, here it is minus 25.3. So if you miss this theta part, you will lose both the questions. So that's why here it is showing negative and here it is showing pi by 2, which is 1.57. So that was the tricky part in this question. And yeah, please this keep this in mind because similar type of questions can be coming in the exam also. So you have to be very careful. Yes.
Once again, sir.
Okay. Okay. So this question, I think you might have all seen this question in the assignment 4. So I think who has asked this? Gyanendra Singh has asked, saying that he's not getting the answer they have given. So he solved using the superposition theorem. He used the voltage source and then he calculated VC by calculating j omega L and j omega C, which he got minus J10 and J2.1. After using the potential divider formula, he got VC1 as 25.3 cos 100t minus 90 degrees. So he substituted 25.3 here and minus pi by 2, which is minus 1.57 here. But he lost both the questions. Why? Because here they have mentioned that theta is greater than minus 90 degrees, which means theta cannot be minus 90. So I cannot directly use this as my answer. I have to little bit tweak it. I have to little bit change it using the trigonometric identities we have learned. Not that this is wrong. It is correct. But the question, there is a tricky part saying that theta cannot be minus 90. So you have to change it. Because according to the question, you cannot write this as the final expression because they wanted in a different way. So I have used the trigonometric identity, which is cos theta equal to cos 360 plus theta, and then 360 minus 90 is 270, which I have written 180 plus 90. So I got this expression where theta is 90 degrees and it is falling within the range. So now my amplitude has become minus 25.3 and theta has become 90, but in his case it was 25.3 and minus 90, so there was a minus sign he had in the angle, but according to the question there will be minus sign on the amplitude. So that's the tricky part in the question. Sir, can you solve the questions related to assignment week 5? Yes, yes, we'll solve. This was the question he asked, so that's why we were discussing that. So if everyone got an idea of what we have discussed, then we'll proceed to week 5. So I'll just give brief introduction about the polarity of the mutual inductance before we proceed on to the problems. So can we proceed, everyone? Any
Yes, sir.
queries you have? Sorry?
Yes, sir.
Okay. So in the week 5, it is all about self and mutual inductance of a coil. But before we go into self and mutual inductance, I wanted to highlight on the aspect like why dot convention is needed and how dot convention like exists or how to get the dot convention. So today's discussion is self and mutual inductance. And one thing I am telling everyone should go through sir's lectures. Don't think that attending this lecture itself will get you all the concepts because I will not get the time and I this session is also not for teaching. I am just summarizing what are necessary and what are very crucial that you should not forget. So those aspects only I'll be covering in this session, but this session is not for teaching. So you should go through sir's lectures in that particular week. Then only you should attend this session, then only it will be fruitful. Because if you directly come here thinking that I'll teach everything, then that won't happen because we don't get time because we also have to solve problems. Then your concepts will not be clear. If you watch those lectures and then come here, then it will be very beneficial because it's like a revision. So first of all, what is dot convention and how to get the dot convention? So dot convention is needed because whenever there are two coils, huh, and there are currents. So how will be the polarity of the mutual inductance part. So in order to get the voltage polarity, dot convention is very much needed. So to to get an idea about voltage polarity, and we'll see that how if the dot is different, how the voltage polarity will change soon. But let us take one example. So let us take a core which is something like this. Okay, and then say the winding is something like this. Okay, so this is my input terminal, and I'm considering the current direction to be in this way, I. Okay, so this is my terminal 1 and 2. So on the other side, we have something like this. Okay, and here we have say connected load. So here we have connected load. Okay, so this is my load, and now they say this is the dot. Okay, say on one side we have mentioned that this is the dot. So on the other side, how are we getting the dot? Say on the left wing, if this is the current direction, how will the flux will flow from bottom to top or top to bottom? You know, a right hand thumb rule. So if you fold your thumb in the direction of the fold your hand in the direction of the current, then the thumb will show the direction of flux. So whether it is flowing from bottom to top or top to bottom.
Bottom to top.
Bottom to top. Very good. So I am marking it uh, with green color, that this is the direction of flux. Okay. So now what is Lenz law? Lenz law says that if what does it say? It says about the direction of the induced current. It will be in that way that it opposes the magnetic field or the flux here that is caused by another current. So let me just state it. So now why we are using Lenz law? We are using it to see what will be the direction of the second coil that is on the right side. So what does Lenz law says? It says the direction of the induced current due to changing magnetic field is in such a way that it creates a magnetic field which opposes the initial changing magnetic field. Okay, so now what it says is the current direction in the other coil, second coil, should be in that way so that the flux will be in this direction. Okay, so the flux should be in this direction according to it. Okay, so if that is the flux direction, what should be the direction of the current? Anyone? So I want the direction of the current in this. So whether it will be from left to right or right to left.
Left
Uh,
to right.
Left to right. Very good. Who is this? Shamita?
Yes, sir.
Yeah, very good. So I hope others are also following. So the direction of the current will be in this way, because then only the flux that created by this coil will be opposing the main flux, which is what Lenz's law is saying. So now let us see that here this is plus and this is minus, right? So on the load side, as the current is uh, supplied to the load, whether the load will have positive on the top terminal or the bottom terminal.
Top terminal.
Top terminal, very good. So now we know the windings. So now we have seen the positive terminal on the input as well as the positive terminal on the output. In such cases, what we'll say is the dot convention will be at the positive side. Basically, same side, plus and plus or minus and minus. So if the dot is on the plus side on the this side, it should be on the plus on the other side. So they will be on the like polarities. So once you know the sense of winding, then you can get the dot convention. And dot convention, once you know, then we'll see how it will help in order to solve a problem where there is mutual inductance. So the conclusion is once the sense of winding is known, dot convention is known. Okay. So because now you know the winding, you understood that this is the dot convention. So what if you don't know? So what if this is unknown? What if this is unknown? So then you have to perform a test. So basically what you will be doing is, say I don't know how the windings are wound. So then we'll give a some positive voltage so that the current will flow in one direction, and then we'll see on the load which is positive terminal. So then the positive terminal on the this winding one and the positive terminal on the winding two both will have the same dot convention. So you have to perform a test. So perform a test which is called polarity test. So perform polarity test to find the dot convention. So is it clear to everyone until this point how we are getting the dot convention? Any doubts? Any queries? Anyone?
No, sir.
No. Others? Clear. Okay. Vishnu says clear. Amit and Parvatam and Savita, Sirisha, Shashidhar. Clear. Okay. Okay. So now we'll see. Uh, till now we have seen that how to get the details about the dot convention. So now the dot convention is known and there are two mutually coupled coils. So then how it is needed? So basically the dot convention is needed, as I have mentioned, to get the idea of the voltage polarity. So now we are discussing about the polarity of voltage in the coils. Clear, sir? Okay. Polarity of the voltage in the coils. So now we'll consider two mutually coupled coils and then a certain dot convention, and then what will be the voltage polarity, and with a different convention what will be the polarity. So there will be two cases here. One is case 1 when current is either entering or leaving the dot in both the coils. What I mean by this, I'll come. So in this case, say I have one coil here, I have another coil here. So now we have two coils, and then say this is my L1 and this is my L2, and say this is dot here and this is also dot here, both have a mutual inductance M. Okay, and then current is entering I1 of t, and here current is entering I2 of t. So in both the cases it is entering. Also you can say in both the cases, if it is leaving, then also it remains the same. So if it is entering the coil, say we are considering entering case here. So if it is entering the coil, how will the polarity of the coils will look like? Okay. So you know that if current is entering the inductor at the terminal, it will have positive terminal, right? So that side of the terminal will have a positive terminal, like positive polarity, right? If something is entering, V equal to LdI by dt, you know that which terminal the current is entering the coil, that terminal will have positive polarity. So in this case, so any question where there are coils, you will convert it into voltage source and then you solve. So first you have all should keep this in mind. First, every time you have to convert this into a voltage source. Then only you start solving the problem, else you will make many mistakes. So basically what we are doing is we'll be converting this into two voltage source. One is because of the self inductance, another one is because of the mutual inductance. Self inductance, mutual inductance. Self inductance, mutual inductance. So the current was initially entering like this, I1 of t, and this is I2 of t. So I will use two colors, orange for the or green for the self inductance. So as the current is entering the left side, this will be plus, this will be minus. Here also this will be plus, this will be minus. So now this will be L1 di1 by dt, and this will be L2 di2 by dt, because the current is entering or leaving the dots in the both the cases, the mutual inductance polarity will also be the same. So if this is plus minus, this will also be plus minus. But if you see here, the term will be M into di2 by dt, because the mutual inductance happens because of the coil in the, because of the current in the other coil. So this will be M into di1 by dt. So any doubts before we proceed into other case, or let me just repeat. So there are two cases. In the first case, current is either entering or leaving the dot in both the coils. So in this case, current is entering the dot in both the coils. In that case, every time you have to draw the voltage sources. So we know that there will be two voltage, like not voltage source, you can say that there will be two voltages that will be coming, one because of the self inductance, other one because of the mutual inductance. So in the case of self inductance, we know that whichever terminal the current is entering, that will be positive. So first we have to write the polarity of the self inductance. One is L1 di1 by dt, the current because of the the voltage that will be induced because of the current in its own coil, L1 di1 by dt, similarly L2 di by 2 by dt. Now because the current is entering, the polarity of the mutual inductance because of the mutual inductance will be same as that of the self inductance. So I have put the polarity. So now the voltage that will be induced in the coil 1 because of the current in the coil 2, similarly the voltage induced in the coil 2 because of the current in the coil 1. So that's why here we have mdi by 2 dt, here we have mdi1 by dt. So is this clear, everyone? If you have any
Yes,
queries,
sir.
please ask, because this is very clear for the problems. So now for case 2, it becomes simpler. It will be just little bit different. So I'm copying. I'll just modify. So this will be my case 2. So current is entering the dot in one coil and leaving the dot in another coil. So current is entering the dot in one coil and leaving the dot in other coil. Okay. So current will be leaving. So the direction will be in the other way. So this will be like this. So now current is leaving the coil, leaving the dot means entering the other terminal. So the current will leave like this. Okay, clear. So now again, so what we'll be doing? We don't know the polarity, but the terms are same, right? L1 d1 by dt. So first let us draw the, yes.
What the dot symbolizes, sir?
So now because uh, like because of the dot, now we know what will be the polarity because of the mutual inductance. Say if current is entering both the dots, then the mutual inductance will have the positive effect. So that side will have the positive terminal. But if the current is entering one dot and leaving the other dot, then it will have some other effect. So in order to understand this, we put the dot convention, because if we do not put the dot convention and if we have to look at the coil every time, then again we have to calculate whether the flux is flowing in this way, so which terminal is positive, which terminal is negative. This becomes very difficult, right? Looking at the coil and getting the direction of flux and doing so. Instead of all this, now we don't have this diagram only, so now we have simplified the diagram and just putting the dot convention. So based on the dot convention, we are learning what is the convention of the polarity, and then we'll directly follow this rather than having this diagram, which will be very difficult. So we are basically converting this into this with the dot convention, which makes our life simpler. And now with the dot convention, we are seeing what will be the polarity, and then we'll follow this polarity for solving the problems. So in this case, current is entering this terminal. So positive will be on the left side here, and negative will be here. Whereas in the other coil, this will be plus and this will be minus. Why? Because it is entering from the right side, because the like polarity, voltage polarity, because of the self inductance will be uh, the positive will be on that terminal where the current is entering. Now because current is entering one and leaving the other, the mutual inductance will be exactly opposite of what the self inductance polarity is there. Here if you
Sir,
see in the
I2
above
will
case,
be entering,
sorry.
I2 will be entering on that side, na, sir.
Yes, I2 is entering in this side. So now what happens is the polarity that we are going to discuss, it will be exactly opposite of the main. In the first case, it will be same because both are entering. But in the second case, it will be the opposite, meaning like there is a negative effect because current is entering one and current is leaving. So previously we had plus minus and plus minus, right? Now we'll have minus plus, just the opposite. Here we had minus plus. If it was the above case, we would have gotten minus plus. Now here we'll be getting plus and minus. So is this part clear? Basically, in the above case, the mutual inductance polarity will be same as the self inductance because current is entering the dots. Whereas in the below case, one is entering, one is leaving. So it will be opposite of the polarity of the self inductance. So first, always you have to write the self inductance polarity, and then you have to see whether the mutual inductance will have the same polarity or the opposite polarity, depending upon whether the current is entering the dots in both the coils or entering the dot in one coil and leaving the dot in the other coil. So there is less than a minute. Maybe this meeting will end. If you have any queries, you can ask before we proceed to problem solving. Like you got the
So,
understanding of this?
sir, that I2 current entering the second coil in the
Yes.
second, but in mutual inductance, you have drawn that in the entering in first coil, first
Sorry.
line.
Oh, sorry. So this one, right? Yeah. Thanks for. Yeah. This is the other way. Yeah. This is your query, right? So is this clear? The polarity, how we are getting everything?
Yes, sir. That I2 current flows to the second through the second coil.
Yes.
Uh, the direction in the mutual inductance, sir.
So this will be the I2 of t. Okay. What was your query? I could not follow.
Yes, sir. That L1 di by dt is the first self inductance. You have written the first voltage
Case two or
distribution.
case one?
A second case, sir.
Okay. Second case.
That L2, current I2 is in the second line of the second coil, right, sir?
Yes.
But L1 and L2 both are in same position.
Okay, see, it is like it is not about the position. Like voltage source, I have okay. So voltage source, I can write something like this. Say we this is sorry. So this is equivalent to this, right? Because the net voltage you have to see. Say this is my minus, this is plus. Say this is V1 and this is V2. So now again here this is minus plus. Say this is V2, this is V1. Both will give the Same expression, because this will give me V1 minus V2 from going left to right, and this will give minus V2 plus V1. So both are same. You are like right. I can write this term here and this term here, but just to maintain like simplicity, I have used the same diagram so that there would not be any confusion. But you can write in any of the way. Both are correct. Because we are just getting the voltage polarity and then we'll apply KVL. So it doesn't matter which one you write first. Irrespective of that, it is still the same in terms of KVL as KCL. Is your query clear now?
Okay, sir. But the first voltage source,
Mm-hmm.
I have written that term di2 by dt. Right, sir?
Yes.
The second
Uh-huh.
mutual, second one, maybe we have di1 by dt. Why, sir?
Because like what is a mutual inductance? Mutual inductance is the voltage induced in the coil 1 because of the coil 2. Similarly, here the voltage induced will be because of the current in the coil 1. So whatever voltage that is induced in the coil 1, that is dependent on the coil 2 current. So that's why we'll get M into di2 by dt. And here we'll get M into di1 by dt because it is mutual. It is not because of the current in this coil. It is because of the current in the coil 1. Similarly, if you see here, this is induced because of the current in the coil 2. And herely this is induced because of the current in the coil 1. So that's why these two have cross terms. So here it will have I2 and here it will have I1 because that is of the mutual inductance. Say if there is no mutual inductance, then these two are not at all coupled. Then this term will become 0. This term also will become 0. So then they'll have only self-inductance terms. But say there is some coupling. So then the rate of change of current in the coil 2 will also induce some voltage in the coil 1 because of the mutual coupling. So that's why it will affect the voltage induced in the coil 1. Similarly, it happens for the voltage induced in the coil 2.
Okay, sir.
Any other queries?
No, sir.
Okay. So let us quickly solve one problem. Everyone, is it clear until this point?
Sir,
Yes.
you have changed the direction of I to now. So then why are you changing polarity of that voltage?
Which voltage? This one or the this one?
Self-inductance.
Yes, self-inductance, because if you see, if this is the direction of the current, the polarity will be plus minus, right? And say if this is the direction of the current, the polarity will be plus minus, right? Because which terminal it is entering, that terminal will have the positive sign because of the self-inductance. Self-inductance has got nothing to do with the dot convention. The dot convention is only because of the voltage polarity due to the mutual inductance, but the self inductance polarity is dependent on the current direction directly. So if the current direction is which terminal the current is entering, that terminal will have positive. Clear now?
Okay.
Or
Yes, sir.
okay, so now let us solve one small problem before we go into the problem solving session. Okay, so the problem is something like this. So coil 1 has voltage like this and coil 2 has been shorted. Okay, and the voltages are given. This is plus minus V1 and the current direction is I1. This is L1. This is L2 and the current direction is here I2 and the dot convention is this. And then there is mutual inductance M. So this comes under case 1 or case 2?
Case one.
Case 1. Okay. So for case 1, first let me make two voltage sources here. So basically the question is, what is the inductance seen by source? What is the effective inductance seen by source? Okay, so here also we have two voltage sources. So first let us draw the self inductance. So in the First coil, whether the plus will be on the left side or right side, whether it will be plus minus or minus plus.
Plus minus.
Plus minus. And on this coil, self inductance.
Plus minus.
Plus minus. Very good. So now the coil current is entering the coils at the dot in both the coils. So whether the mutual inductance will have the same polarity or the opposite polarity.
Same polarity.
Same polarity. Yes, same. Nandini is also saying same. Yeah, very good. Plus minus and plus minus. So after doing this, now I'll write which is what. So this is L1 di1 by dt. This is L2 di2 by dt. And then this is M di2 by dt. And then here this is M di1 by dt. And this voltage is V1. So let us apply KVL here and then KVL in the other one. So here we'll get V1 minus L1 di1 by dt minus M di2 by dt equals to 0. Agree everyone?
Yes, sir.
Okay. Now on the RHS side, what will be the expression? On the RHS side, we'll have L2 into di2 by dt plus M into di1 by dt equals to 0. So basically I want to eliminate di2 by dt. So I'll calculate what is my di2 by dt, which is minus M by L2 into di1 by dt, right? Agree everyone? Whatever calculation we are making.
Yes, sir.
Yes. So now if you substitute that, can you tell me what will be the final expression that we'll be getting? Say, I will write the expression something like this, that V1 equal to L effective into di1 by dt, because that is the effective inductance seen by source. Now, after substituting it, can you tell me what is the L effective value that we'll be getting? So you substitute di2 by dt and then convert it into this form. So what will be my L effective in terms of L1, L2 and M? So this will be L1.
Sir, L1 L2 minus M square divided by L2.
Okay. Or L1 minus M square by L2. So we will be getting L effective equal to L1 minus M square by L2. Everyone is getting the same expression?
Yes, sir.
Yes, sir.
Everyone. Right. Anyone facing any issue?
No, sir.
Okay. So this is one simple problem we have taken. So this is how we'll be proceeding to solve the problems. In the given question, first we'll write the voltage sources, then we'll apply KVL, and then we'll solve for whatever asked in the question. Clear, right? So we can proceed for the problems.
Yes.
Okay. So this is the assignment 5. So first question, if you see, it has three sub questions. They're asking what is I1, I2. Okay. So this is assignment 5 from the year 2024, and this will be our problem 2. Okay. So now if you see, there are many things because there are three coils and three are uh, like coupled. So say this one is my coil one. Let me mark so that it will be easy. Say this one is my coil one, or let us use a different color because red is already there. Say this is coil one, this is coil two, this is coil three. So I2 again is coming here. So coil 1 and coil 2, which under which case it will follow, like fall, case 1 or case 2?
Case 2, sir.
Case 2.
Case
Everyone
2.
agree? Yes. Now coil 1 and coil 3.
Case ones.
The case.
Case 1. Very good. And coil 2 and coil 3.
Case two, sir.
Case 2. Very good. So now if you see here we have one because of the self inductance and one because of the mutual inductance. But if you see here, there are two mutual inductances because one is coil one is connect mutually coupled to coil two, coil one is also mutually coupled to coil three. So basically we'll have three voltage sources for each coil instead of two. Understood why we'll have three?
How, sir?
Because one because of the self inductance of this coil, one because of the mutual inductance between 1 and 2, and another because of the mutual inductance between 1 and 3, because it is coupled to two coils. So there will be two mutual inductance terms and one self inductance term. Got
Three
it?
mutual inductance, na, sir.
Two mutual inductance, because this is mutually coupled to this and this is mutually coupled to this. I am talking about coil 1.
The
When I'm writing the polarity of coil 1, it has three voltage sources that will be coming. One is because of its self inductance and another because of the mutual coupling with the other coils. It is mutually coupled with coil 2, mutually coupled with coil 3. So it has three terms. Similarly, if I write coil 3, it also has three terms. One because of the self inductance, and another because of the mutual coupling between 1 and 3, and another between 2 and 3. Similarly, for coil 2, one because of its self inductance, another because of the mutual coupling between coil 1 and 2, another between the mutual coupling between 2 and 3. So each coil will have three voltage sources, not two, because they here the coupling are 3 overall compared to the 2 in the last case. Here we have two coils, one mutual. Here we have three coils and three mutual. So that's why it is a little bit difficult, or I could say more number of sources. Everyone got it? Why three sources we have?
yes, sir.
Yes. Everyone got it, right?
Yes, sir.
Yes. So now
Yes,
the
sir.
yes, yes. Okay. So now is the very crucial part, which is the voltage source. Writing the voltage source polarity is itself the difficult part. If you make any mistake, then it will be wrong. So every, so there is one, two, three. Have a voltage source. So now here we'll have six instead of one, two, three, four, five, six. Three for that and three for this. And what is connected in the load? Load has a resistor. Okay. So load has 5 ohm. This is 5 ohm. Okay. And source is how much? 220 volt.
This is DC source, na, sir.
Okay. You tell me whether it is DC or AC. So from the symbol, what do you think it is? AC or DC?
AC, sir.
AC, right? So 220 volt RMS. So let us consider 220 volt angle 0. Okay. So first what we'll do is, first we'll write the polarity of the self inductance. So for the coil 1, because of the self inductance, whether the plus will be on the top or plus will be on the bottom.
Top, sir.
Top, right? So self inductance, I'm using the green. So plus and minus. Plus on the top and minus on the bottom. And the value will be what? J36 into I1, right? Because it's self inductance into its own current. J omega L into I voltage. Clear, everyone? Any doubt? We have to go step by step, and everyone should be like clear at each and every step, because it will become difficult if you don't let me know if you have any confusion. So we'll go slowly, and at every step you just let me know if you have any queries or if we can proceed further. So J36I1 is clear, right, for everyone?
We should use
Sorry.
we should use LDI by dt, no, sir.
LDI by dt. So either we'll use in time domain, or we'll use in this J domain, right? Like in last class, last week, if you see, how did we write the voltage across the inductance? We have written voltage across the inductance can be written as LDI by dt, or voltage across inductance can be written as J omega L into the current it is flowing, right? In the phasor domain, basically. Time domain or phasor domain? Frequency domain, or you can say. So it's inductance into its current phasor, right? Impedance into current phasor. Got it?
Yes, sir.
Okay. Shamita, you got it? Hello? Shamita, are you there?
No, sir.
Yes, sir.
Okay, got it right? Any confusion?
Voice is breaking once again, sir.
Okay, you got the thing that I have explained, or you still have any confusion? Yes, sir. Okay. So now for coil 3, because of the self inductance, the polarity plus will be on the top or at the bottom?
Top, sir.
For J16, because of the self inductance.
Inductance, sir.
Self inductance. No mutual. We are not yet touching mutual now.
Respect to 1 or 2, sir.
Sorry.
With respect to 1 or 2, sir.
3. The self inductance of coil 3, what will be the polarity? Like how we have written for coil 1, for coil
Plus
3, I want to write. So,
bottom is plus
sorry, plus at which terminal, bottom or top?
bottom.
Bottom. Others agree or any query? Bottom. Nandini is
Bottom,
also
sir.
saying bottom. So it is at the bottom, right? Because whichever terminal it is entering, that terminal will have positive terminal. And what will be the voltage value? Bottom. So Narsha is also saying bottom. So what will be the voltage value? J omega L into current, right? So what will be the value?
J16 I2.
Yes, very good. So plus on the bottom, minus, and J16 I2. Okay. Now for the top coil, minus, sorry, plus terminal will be at the bottom, or plus terminal will be at the top?
Bottom.
Bottom. And what will be the value?
J14 and I2.
Yes, very good. Others agree?
Yes, sir.
J14 and I2. So the easiest part is self-inductance. Yes, sir. Nandini is also saying yes, sir. So self-inductance is done. Now, if the mutual inductance falls under case 1, then the polarity of the mutual inductance will be same as the self inductance, else it will be the opposite. So first we'll do coil 1 and 2, then we'll do coil 2 and 3, then we'll do coil 1 and 3. So coming to coil 1 and 2, so coil 1 and 2 will fall under which case, first case or second case?
Second case, sir.
Second case. So the mutual inductance will have the opposite polarity of what the self inductance has, right? So the mutual inductance will have the same polarity or the opposite polarity?
Opposite polarity.
Opposite polarity. So now the opposite polarity means what will be the term? So the term will be mutual inductance into the current in the other coil. So in the coil 1, what will be the term in terms of j omega L into L?
J 9.6 I2.
Yes, very good. So first of all, it will be the opposite polarity. So it is plus minus. So this will be minus plus. So it will be j 9.6 into I2. Similarly, here also it is plus minus. So we have minus plus j 9.6 I1. Everyone agree or any confusion? I have done coil 1 and 2 mutual inductance term. So that's why I am representing in the same color. So this is basically coil 1 and 2. Any doubts, anyone? Or is it clear? Please
No,
respond
sir.
so that I'll understand. Shamita, Amit, Vishnu, everyone, is it clear? Yes, sir, clear. So now let us come back to coil 2 and 3. So coil 2 and 3 will be in case 1 or case 2?
Case 1,
Case
sir.
2, sir.
Case 1 or
Two.
case 2? Case 1.
Case 2.
Check whether the current is entering the dots or one it is entering and one it is leaving. Coil 2 and 3. Someone is saying
Case
case
2,
2?
sir.
Case 2. Everyone
Yes, sir.
agree? Case 2. So case 2 meaning opposite polarity with respect to the self inductance. Okay. So green is our base. Every time green is our base. Every time you have to write the polarity with respect to green because that is the self inductance. So now what will be the voltage value for coil 2 and 3 in terms of j omega L into I?
J 8.4 I2.
J 8.4 I2 and J 8.4 I3. So in the first case,
I3.
yes. So here it will be in the opposite polarity with respect to green. So plus on the bottom means here plus will be on the top. So minus plus J 8.4 I3, right? Similarly, here it will be in the opposite polarity. So minus and then plus J 8.4 I2. Everyone agree or any question, any query?
Sir, I2 and I3 are same.
Oh, sorry. Yeah, yeah, very good, very good. My
So,
bad, my bad.
they also I2.
I2 and I3 are same, yeah.
I,
Yeah, I was. Thanks for pointing it out. So this is basically both are I2 because I2 and I3 are same. So yeah, thank you. So is this clear until this point? So we are doing one by one, step by step. If you see, I'm coming, like I'm coming in a like step by step process in a particular way. First, I have done the self inductance because with respect to that polarity is different. After writing the self inductance, I have gone to coil one and two. I have written coil one and two. Then I have come to coil two and three. Now after completing this, now I'm going to coil one and three. So you have to follow this step process so that you will not be confused and not make any mistake. If you mess up one polarity, then your entire problem will be wrong. So you have to be very careful with the polarity. And also I'm using this color combination so that you will know which is mutually coupled to with what. Green is the base, which is the self inductance. These two are for 1 and 2. These two are for 2 and 3. and this is now these two will be for 1 and 3. So coil 1 and 3, under which case they'll fall? Under
Case 1.
case 1. So it will have the same polarity as the self inductance. And what will be that expression? I mean value?
J 9.6 I1.
Yes, J 9.6 I1 and J 9.6 I2. Yes. So I will be using a different color, which is a blue color, plus it will be the same polarity. So plus and minus J 9.6 I2. Here also it will be the same polarity of this. So plus and minus J 9.6 I2. Clear until this, or any queries you have? Or sorry, this should be J 9.6 I1. This is I1, right? Because of the coil 1. Clear or any queries? So now that we have drawn, now we have to apply KVL in the left side and the KVL in the right side. So now that we have drawn, let me just slightly move so that we can write.
What we should find in this question, sir?
Okay, so in this question, they have asked to find I1 and I2. So I'll just slightly reduce the size so that we can see and write. Okay, so first write KVL here, one equation, and then KVL here, another equation. So we'll solve for I1, I2, two equations, two unknowns. So I am starting from here and then traversing in this way. Same, I'll also be starting here and then traversing in this way. So in the first one, we'll have what? 220 angle 0, and then tell me, and then plus or minus.
minus minus J 36 I1
Okay,
plus J 9.6 I2
okay,
minus J 9.6 I2 equal to 0.
yes. So now if you see, two terms are getting cancelled. So this term is getting cancelled, this term is also getting cancelled. So now can someone calculate I1 in terms of phasor and tell me? So basically, if I further solve, I'll have I1 equal to 220 angle 0, 220 angle 0 by J36. So now tell me what is the value of I1 in terms of phasor. So
Minus J 6.11
okay, you should not say in
minus
J, you should
J
say R angle
6.11
theta. Huh.
6.11 angle 90 minus 90 degree.
Yeah, very good, very good. So who is this? Amit Singh.
Amit sir.
Amit Singhal. Okay, okay, very
Yes
good.
sir. Yes.
So 6.11 angle minus 90 degrees ampere. Everyone getting it? Any confusion?
Yes, sir. Yes, sir. Clear.
Clear, right? So now we'll go in the KVL in the second. So what about Gyanendra, Narsaya, Parvatam, Shamita, Nandini, Shashidhar, Somnath, and Vishnu? Until this point, is it clear?
Yes, sir.
Yes,
Okay.
sir.
Yes,
Okay.
sir.
Now in the KVL, in the second coil, we'll apply KVL. So we are starting at the bottom. We'll go through, and the current is I2. So this current is I2. Okay. So now tell me what will be the KVL.
Sir 5 I2
Okay. So we are coming in the. So we are starting at this point, bottom point. So tell from
yes
J16 I2.
minus J 16 I2
Okay. So I'll write in a different color. Minus J16 I2. Okay.
plus J 8.4 I2
Plus J8.4 I2.
minus J 9.6 I1
Okay.
minus J 49 I2
Okay.
plus J 9.6 I1
Hmm.
plus J 8.4 I2
Okay.
plus 5 I2 equal to 0.
Minus 5 I2, right? Because this is plus and this
Sorry,
is
sorry,
minus.
sorry, sorry. Minus I2.
Minus 5 I2 equal to 0. Yeah, very good.
I2 equal to 0.
If you see again here also two terms are getting cancelled, this term and this term.
So is it 4.9 or 49, sir?
49, 49. I think there is given 49, 49, 49.
Okay, sir.
Okay, so now what is the value of I2? Anyone? It's very simple. You can look at the equation and tell. No calculator,
0, sir.
nothing. Yeah,
0,
very
0,
good.
sir.
0, 0, 0. Very good. So it is simply 0. Okay. Let us go back to the question and see what they have asked. They have asked I1 and I2. Let us see whether our values are matching or not. So if you see, they are asking what is the I1 RMS value. So what is the I1 RMS value? Anyone? What is I1 RMS
6.11.
value?
6.11.
6.11. And I2 RMS value?
0.
0. So 6.11. So it is in the range. And I2 is 0. And they're asking what is the potential difference between VAB. So this is A, this is B. So we have to go from VA to VB. So let us go. They have given this is VA and this is VB. So let us go from VA to VB. So VA minus or plus VA plus or minus J9 49I2. We are going from VA to VB. So let us write the equation KVL. So VA plus or minus J49I2. Anyone? Will it be plus or minus?
Minus J.
Minus J49I2 and then
How minus, sir?
sorry.
How
Uh,
minus, sir?
because if we are going like say I'm going in this direction, right? So basically we are going in this direction. So when we are crossing J49I2, we are going to a lower potential. So that's why it is minus, because we are going to a lower potential. If we are going to higher potential, then the potential that we are gaining is positive. If we are going to lower potential, then the potential that we are gaining is negative. So that's why negative. And then plus or minus J 9.6i1 complete. Anyone? What will be the equation? Until VB, we have to write the expression.
Plus J, plus J 9.6 I1
Okay.
plus J 8.4 I2
Plus J 8.4 I2 equal to VB.
equal to VB.
Yeah, very good. And if you see, because I2 is 0, I can directly ignore this term and this term. So now VAB is nothing but minus J 9.6 I1, right? So VAB equal to minus J 9.6 I1. So someone please calculate and tell me the value VAB in phasor.
So, how you took VB on that side, sir?
Like say I am going in this way. So I'll give you one small example. Say this is there, like this it is there. Say this is my VB and this is my VA. Say this is 5 volt, this is 2 volt. So by looking at the circuit, you can say that VAB is how much? Just
Minus 7
VA is at higher potential or VB is at higher potential?
VA.
VA. So VAB will be what?
Minus 7 volt.
If VA is at higher potential, how can VAB is minus 7? VA with respect to VB. So VA is at a higher potential with respect to VB or at a lower potential?
Higher potential because plus is connected to VA.
Yes. So VA minus VB will be positive or negative?
Positive.
So then why it will be minus 7?
Because it is going from plus to minus.
Uh-huh.
Okay. I got it.
Yes. So this will be 7 volt. Now if I write the KVL in the way I have written, I can write VA I'm going from A to B. So VA, and then I'm stepping it down -5. Then I'm again stepping down -2 to reach VB. So now if you see VAB equal to 7 volts. So in either case, it's the same. But if you see from VA to VB, you have to go down 7 volts lower to reach VB. So that's why VA minus 7 equal to VB. Clear, everyone? Okay, so 58.6 angle 180 Gyanendra. Vishnu is saying 58.65. So the will be 58.65 angle 180 degrees. Very good. So it will be 58.65 angle 180 degrees volt.
Sir,
Yes,
sir,
Minus
sir,
180
there is
ADPI.
one doubt.
minus 180. I was getting 180. Can anyone cross check? Both are
So,
same. Minus 180
sir,
plus 180 both are same. Sorry.
sir, there is one doubt.
Yes,
Why we cancel out minus J 49 I2 and J 8.4 I2?
because I2 is 0 na.
Acha, I2 0. Okay.
Yes. Minus 180 and plus 180 both are same because theta equal to 360 plus theta. So VAB is 58.65. Let us go and check. It is 58.65. It is matching. So in this problem, they have three coils which are mutually coupled. So the steps that everyone should follow is first draw the number of voltage sources, then write the self-inductance polarity, then come to mutual coupling, and then go step by step. 1 2 coupled, 2 3 coupled, 3 1 coupled. Step by step you have to follow and first see whether they are in case 1, case 2, and then write the all the polarities, all the voltages, then apply KVL to solve for I1 and I2. There is less than a minute, so this meeting can end at any time. So if you have any queries, you can ask before we go to other problem. Everyone, is this clear?
Yes, sir. Clear, sir.
Okay, so
Sir,
we'll go to other problem.
8.4. Sir, how 8.4 will come, sir? J 8.4 I2.
Someone was asking something and the meeting got ended. Who was asking? Nandini or Shamita? Someone was asking. Should we proceed to next question or do you have any further queries?
Yes, sir. But,
Okay.
we have a J16. We have take it as it is, but J36 and J49 are we have changed it to 8.4 and
Not getting, your voice is broken. Hello?
sir. How do you get that 8.4 and 9.6, sir?
Okay, so this 9.6 I1 is because of the mutual inductance with the coil 1. So there is mutual inductance J 9.6. So that's why here I got J 9.6. And this J 8.4 is the mutual coupling between this coil 2 and coil 3. So here we have one J 8.4, here we have another J 8.4. Similarly, J 9.6 here, J 9.6 here. And then this 9.6 is between coil 1 and 3. So that's why J 9.6 and J 9.6.
Okay, sir. Understand.
Okay. So let us solve another problem. This problem is also very good. Uh, Probably I think this will be the last problem for today. If you see, there are like the number of coils, like mutual inductance are reduced. But if you see, there are like two, here one and here another. Whereas here you have mutual. Here the number of voltage sources will be more. Here it will be comparatively simpler. So they're asking what is the RMS value of I1, I2, I3, and V2, V3. So first we have to solve for I1 and I2 and I3. So that will be our main concern. So this will be problem 3. Okay. So this will be our problem 3. So they have given the direction of currents. So this is I1 and this is I2 and this is I3. So directly you tell me whether okay. So they say this is our coil 1, this is coil 2, this is coil 3, this is coil 4. So coil 1 and 2, whether they will fall under case 1 or case 2. Similarly, coil 3 and 4.
Case 2, sir.
case 2. And coil 3, 4,
Also case 2.
case 2. Very good. Okay. So now, how many voltage sources we have to draw for each coil in this case? 2. Nandini is saying 2. What about others?
2, sir.
2, sir.
2. 2. 2. Because there is only one mutual inductance term and one self-inductance term. Everyone agree?
Yes.
Yes. So first, what I'll be doing is I'll draw the voltage sources. Then I'll start entering the values. So here we'll have 1, 2, and this is the AC source. So this is 125 angle 0 degrees volt. This is 1, 2. Here also we'll have 1, 2. Here also we'll have 1, 2. And then we have capacitance. So capacitance is minus J 50 ohm, and this is I3, this is I2, this is I1. So first, every time start with self-inductance. So for coil 1, because of self-inductance, polarity will be at the top or bottom?
Bottom, sir.
Okay. What about others? Because of self-inductance for coil 1. Coil 1 is J9 ohm. Current is entering which terminal and the polarity will be at which terminal? Self-inductance. Now you should be able to tell it quickly because that we have solved one problem and you have understood. Top. So Nandini is saying top. Someone said bottom. So what about others? Is it top or bottom?
Top positive,
Top,
sir.
sir.
Top, right?
Top, sir. Top. Top,
Yes.
sir.
Yeah. So it will be top. And what will be the voltage value?
J9 I1.
Yes. J9 I1. Very good. For coil 2, the polarity will be at the bottom or top? You have to check coil 2 whether current is entering from bottom or current is entering from top. So wherever it is entering, that terminal will be positive.
Minus top, sir.
Minus
Minus
top.
top.
So plus on the bottom. And what will be the value?
J25 I2.
Yes, very good. Now for coil 3, positive on the top or positive on the bottom? Everyone should
Positive on
equally.
top.
Yes,
Positive on top, sir.
positive on top. Very good. What about others? Are you following? And for coil 3? Minus. Minus on top or minus on bottom?
Minus top. Minus top.
Minus
Top.
Yes. Value?
J49 I3.
J49 I3.
Yes, very good. Others, are you able to follow how we are getting this? Any query until this point? So we till now we have done self-inductances. We are following the same convention, green color. So now with respect to this, because it is case 2, mutual inductance will have the negative polarity. So we know the negative polarity directly. We know the mutual inductance. We know the current. So easily we will be able to write. Right? So for this term, on the coil 1, mutual inductance, what will be the polarity of the voltage polarity because of the mutual inductance? Plus will be on the top or bottom?
Bottom.
Bottom, right? Because it will be in the opposite. So plus is top there. So plus is bottom. And what will be the value?
J 7.5 I2.
Okay. Yes, very good. So here, what will be the polarity? Plus on the top or plus on the bottom? This coil 2.
Plus on top, sir.
Plus
Plus
on
on
top.
top.
Very good, because it is the opposite. And value?
J 7.5 I1
Yes, very good. And then coil 3. Again, this is also case 2, so opposite polarity.
minus on top.
Okay. Value?
J 28 I3
Yes, very good. And for the fourth coil?
plus on top.
Very good. Value?
J 28 I2
Yes, very good. Others, are you able to follow? So I have maintained the same uh, convention. So these
Yes,
two are
sir.
coupled, these two are coupled. Shamita and what about
Yes.
others? Nandini, Amit, Gyanendra Singh,
Yes,
Narsaya, Somnath Das,
yes, we have
Vishnu.
followed, sir.
No doubts, right? Yes, sir, clear. Okay, so any doubts?
Yes, sir. Suppose I1 and I2 are in case 1, then the mutual inductance is it the same polarity or opposite, sir?
First we have written the self-inductance. So now because it is in the case 2, the mutual inductance in the coil 1 will have the opposite polarity with respect to the self-inductance in the coil 1. Similarly, the mutual inductance polarity in the coil 2 will be opposite with respect to its own self-inductance. So for that reason, I have first written self-inductances. So now this will be opposite. So minus plus means plus minus. Plus minus means minus plus. Minus plus means plus minus. Plus minus means minus plus. So that's how the polarity is. Now, is it clear or you still have any confusion?
Yes, sir. Actually, my doubt is the I1 and I2 are the case 1.
Yes.
Then, what about the polarity of mutual inductance, sir? Is it same with the self inductance
Yes,
or
yes. Same.
okay, sir?
So if I1 and I2 say if it here also it is entering, then if this is minus plus, this will be also minus plus. But now I2 is entering the dot. So first of all, this will be plus minus because it is entering the dot. So this will be plus minus. So this also will have the same polarity with respect to plus minus. So this also plus minus. So all will be plus minus plus minus plus minus plus minus. Is it clear?
Okay, sir.
Yes. Okay, so now let us write KVL here, and KVL here. So anyone, please volunteer and tell me what will be the equation for KVL in the loop 1, loop 2, and loop 3.
Sir 125
Okay.
minus J 9 I1
Angle 0 degrees minus
plus
J
J
plus
plus
J
J 7.5 I2 equal to 0.
equal to 0. So now I'll directly write the simplification because math you can do. So if you calculate I2 from here, so I'm writing this expression, you can just cross check. I will calculate I2, everything in terms of I1. So I want to calculate I1 first. So if you write I2, you will get 1.2 I1 minus 16.67 angle minus 90 degrees. So this I'm considering equation 1. So just
How we are
everyone,
right?
sorry.
How you wrote that equations? Right is equal to 1.
So I have taken J 7.5 I2 in the RHS side and divided LHS and RHS by minus J 7.5. So you make this calculation and just let me know whether you are getting the same expression or not.
Got it, sir.
Got it? Okay. Others, please do because this is simple math. Let us not spend time on this because I want to solve another problem today. So math part you have to do quickly. So that's why I have written that expression directly because the like intention is to make you reach till this point. So from now onwards, it is just a math which you will be able to do. But I am giving it so that even if you are not able to get this expression, you will understand the flow. Later, you can try and see whether you are getting this expression. So now in coil 2 or loop 2, what will be the equation? Anyone?
J 7.5 I1
J 7.5 I1. Okay, let us use a different color. J 7.5 I1
plus J 25 I2
minus or plus?
Sorry. Minus J25 I2
Okay.
minus J25 I2
Hmm.
plus J28 I3 equal to 0.
Okay. So now what you have to do is you have to substitute this I2 in this equation and then get I3 in terms of I1. So this also I'm just writing the expression. You just check. So it some math, you just have to substitute that and combine I1 terms and constant terms separate. So you'll get 1.875 I1 plus 29.761 angle 90 degrees. This will be my equation 2. So I'm just giving you 2 minutes. Just check whether any one of you are getting this expression or not. Basically, I2 I'm substituting. So I'm converting I2 in terms of I1, I3 also in terms of I1. So that first I will calculate I1, then I will calculate I2, I3, and whatever voltages they have asked.
We shall solve the three equations by substituting. See?
Yes. So basically we have I1, I2, I3, three equations, three unknowns. So what I'm trying to do is I'm converting everything into one variable. So it will be one equation, one unknown. Then I'll substitute I1 into I2 in, I1 in equation 2 to get I3. So I'm converting into single variable. So let us see who will solve and cross check. Yeah, although I'm just skipping math, I have also solved this before today's session. So everyone should solve these things because I am solving. You cannot skip because you cannot escape from this in your assignment or exam. So everyone should solve. But because we are running out of time, I'm just giving the expression because this math you can do later. But I want to discuss as many problems as possible in this session. So we'll cover wide range of varieties in this session. And anyway, this is uploaded to YouTube, so you can always refer if you miss some math and you can do it later and then cross check with the equations that I am getting.
Got it, sir.
Got it? Okay. Who is this?
Amit Singhal, sir.
Amit Singhal. Okay, very good, very
Amit
good. So
Singhal.
you are getting this expression, right? Now, in the loop 3, what will be the expression? J28 I2, whether it will be plus or minus?
Plus
Plus. So J28 I2 and then I3
minus J49 I3
minus J49 I3, then
plus J50 I3
yes, so it will be minus of negative minus
minus of minus.
J50. Yes, very good. Equal to 0. So now if you do, you will get J28 I2 plus J I3 equals to 0. So now basically what we'll be doing is we will substitute I2 in this equation and also I3 in this equation. So now we'll get everything in terms of I1. And if you solve, I am just skipping, you will get I1 equal to 13.993 angle minus 90 degrees ampere. Just maybe you can substitute and see whether you will be getting this or you should be getting this expression. So what we have done is from equation 1, I have calculated I2 in terms of I1. From equation 2, I have calculated I3 in terms of I1. And in equation 3, I have substituted both to get a single equation in terms of I1. And once you solve for it, you will get I1, something like this. So now this I1 I will substitute in equation 1 to get I2, substitute it in equation 2 to get I3. Yes? Yes, tell me.
Sir,
Yeah,
how you got the equation, sir?
this equation. So this equation I got from this loop 3. So from here to here it is increment. So plus J28 into I2. And from here to here it is decrement. So minus J49 I3. And in the capacitor, this is the polarity, right? So this is plus, this is minus. So decrement. So negative of its impedance, which is minus J50 into current I3. So minus minus will become plus J50 I3 and minus J49. So it will be plus J I3. This is J28 I2 equal to 0. So now I am asking you to substitute this here and this here. And then because first of all, you can cancel J. So it will be 28 I2 plus I3 equal to 0. So 28 into I2 plus I3 equals to 0. Once you calculate that, you will be getting this expression. So I
Sir,
asked.
sir, I2 equal to minus J 0.1216.
Okay. So I1
Minus
also you were
J
getting right.
0.1216.
Okay. Good. Very good. So I1 you have calculated. I2 also, if I calculate in R angle theta, it will be 0.1246 angle minus 90 degrees ampere. So I am writing down the values that I have obtained.
How to convert polar form to rectangular forms?
Okay, I'll explain. Let me just write I3 value also. It will be 3.524 if you calculate 90 degrees, because I'm writing this because you can do this later also, because this is just math. And as this video will be available on YouTube, you can always come back and cross check. So if I have A plus IB,
So I'm getting I2 equal to 0.1216.
1216, it is still okay.
Yes,
Maybe
sir.
I have taken more decimals. Until 2 decimals, if
Yes,
it is
sir.
matching, it should be okay. If I consider more decimals, then it will be a little bit more accurate. If you have considered up to 2 decimals, then it will be slightly deviating. But until 2 decimals, if it is matching, it is okay, because in the like in the answer, they'll mostly ask for 2 decimals and they'll give a range, so it should be okay. So if it is A plus JB, if I am converting into R angle theta, so my R will be square root of A square plus B square, and theta will be tan inverse B by A. So now, if I have 1 plus j, magnitude will be root 2, angle will be tan inverse 1 by 1. So it will be root 2 angle 45 degrees.
Sir,
Clear?
for first equation, I'm getting different answers.
This one. This one. Which equation? Equation 1.
Yes, sir. Yes, sir, I converted.
No, first of all, it has 2 terms, whether first term is matching or not.
No, s-
See, first term is what? Minus j9 by minus j7.5, right? Right or no?
here I1 is there, the I2 is there, so we can't subtract nothing.
No, no, I'm saying if I take this minus j7.5 I2 in the RHS side and divide by minus j7.5 on LHS and RHS will have I2, so I2. And I1 coefficient will be minus j9 by minus j7.5, right?
Okay, sir.
Then it will be 1.2 I1 and 125 angle 0 by minus j7.5. So minus j corresponds to minus 90 degrees or plus 90, because here I have put minus. So 125 by minus j7.5. 125 by 7.5 is minus 16.67, and j 1 by j is nothing but 1 minus 90 degrees. So you'll get this expression. Maybe for the time being, you can assume that this is coming. Later you can solve, because I would like to go to another problem, which is also a little bit important. So the math part you can do later. It is simple. And as the steps are mentioned, you can cross check. If you see, I1 is 13.993. So I1 is 13.993 in the range. And I2 is 0.1246. 0.1246. It is also in the range. And I3 is 3.524. So 3.524, it is also in the range. So simple. Now they're asking what is the value of V2, what is the value of V3. So what is the value of this V2, what is the value of this V3. So V2 is nothing but what? So this voltage, right? So this is plus minus V2 and this is plus minus V3. So V2 is nothing but minus J28I3 plus J25I2, right? V2, what is V2? Minus J28I3 plus J25I2, right? Agree or anyone? What is V2? Minus J28I3 plus J25I2, right? Amit?
Yes, sir.
Okay.
Yes, sir.
So V2
Yes,
is
sir.
minus J28I3 plus J25I2. So if you calculate using this, you will get V2 is 101.8325 volt minus J28I3 plus J25I2. Now if you calculate for V3, it will be minus J50 into I3. So V3 is minus J50 into I3. So if you calculate this again, you will get V3 equal to 176.2 volt. You can calculate and cross check. So V2 is 101.8325. So 101.8325 in the range. And this is 176.2, which is also in the range. So anyone has calculated and checked whether you are getting the same expression or not? Anyone was able to get this expression?
Sir, what is V3? V3. What is
V3
the
is
value of V3?
1 minus J50 into I3. So I got 176.2. So basically 50 into 3.5. So 50 into 3 is 150. 50 into 5 is, I mean, 0.5 is around 25. So it will be in the range of 175. And minus
Sir,
J is,
so I think V3 is minus of minus J50 into I3. I think cross check
no, no,
one time.
because this is plus, right? And this is minus. So when I am going
So
from bottom to,
minus of minus J50 into
no, no, the
I3.
top terminal is positive, right? Say, forget about this. Instead of minus J50, say if it is Z. So now what will be V3 in terms of Z and I3? I3 into Z, right?
Okay, sir.
Getting, because the top terminal is positive and the bottom terminal is negative. Say the impedance is Z. So now V3 will be Z into I3. Now if you substitute Z, it will be minus J50 into I3. Got it or any confusion?
No, sir, no confusion.
Got it. Okay. So others, any confusion?
No, sir. Got it.
Okay. So in this question, they're asking what is the coefficient of coupling and what is I1, I2. So it is like simple problem. So we'll go a little bit fast. And then what is the impedance seen by the source? Impedance seen by the source means source voltage by source current. So yeah. So someone has mentioned something in the chat. Clear. Okay. So we have solved how many? 3 problems, right? So this will be our 4th problem if I'm not wrong. Yeah. 4th problem. So this will be problem 4. So first of coefficient of coupling is there is a formula which is k equal to m by square root of L1 L2. So here this is m and this is L1, this is L2. So from this, can you tell me what will be the value of k? This is how it is defined basically.
M is 2.4.
Okay, only 2.4.
J 2.4, sir.
K value. I'm asking what is the value of k if k is m by square root of L1 L2. Someone is saying 0.2. What about others? Okay, what is square root of L1, L2?
Sir, sir, if omega is not given, so how to calculate the L1 and L2? Because the impedance
No, J omega L itself
known,
is
right?
J 2.4. It already includes omega.
So there is in the question they not given that this impedance will be included in omega. So how can we judge that J9 is JL? Right? Omega is not given in the question.
No, like whenever say the inductance, what is the value of inductance? It is J omega L. So whenever someone is giving in terms of J, it means omega is already included. So J omega L is J9 and J omega L2 is J4 and J omega M is J 2.4. So omega is already there
Mhm.
because it is in
So I got it, but the unit of inductance is Henry, right? So
unit of inductance
that
is
unit is
Henry.
given in ohm. So
Unit of inductance.
how can we assume that omega is included? Because unit of inductance is Henry, and the unit is given in ohm, which is impedance. So
Okay,
how
yeah.
can we assume that? That will
Yes,
be
yes.
fun.
So unit of inductance is Henry. Unit of capacitance
Point
is
four, sir.
Farad. Yes, so zero point 0.4. Okay, we'll get back to it. Yes, it is 0.4 if anyone has calculated. Unit of L is Henry, unit of C is Farad. But unit of J omega L, unit of 1 by J omega C, and unit of R, all of this unit is ohm. Because J omega L is radians per second into Henry, that is also ohm. So basically the unit of impedance. So basically this is nothing but impedance or reactance. These will be reactance and resistance, or you can say I'll generalize R plus Jx. It is an impedance, right? So the unit of impedance will be always ohm. So if it is in ohm, it means it is included. Omega is included. Clear now?
Sorry, sir. This point I think not clear. Uh, 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 my point of view that value of L1 is 9 by omega 1, 9 by
Yes.
omega.
Yes.
L2 is value of L2 is 4 by omega,
Yes.
and value of M is 2.4 by omega. So
Yes.
omega will be cancelled out.
Yes. Exactly.
That is my point, sir.
Yes. Got it. Okay. If that is your point, then it is fine. Okay, got it. Yeah. Because even if I put omega, then also it's fine. Yeah. You are right. Got it. Now yeah, you got your question. Okay. So now this is under case one or case two. Let us go a little bit faster.
Yes.
Case
2, sir.
two. Very good. So how many voltage sources will be there in this question for each coil?
It's one self-inductance and mutual inductance.
Yes, very good. So two each. And also we have two. And then this is short right? 50 angle 50 angle 0 degree. So first self-inductance. So self-inductance of J9, positive will be on the top or bottom?
Top, sir.
Top. Plus minus J9 I1, right? So now for J4, whether positive will be on the top or bottom?
Bottom.
Bottom. Very good. This is J4 I2. Now coming to the mutual inductance part, it will be opposite polarity. So minus will be, plus will be on the top or bottom?
Plus is top,
Plus on
sir.
the bottom.
Plus on the bottom because it's opposite, case 2, right? So if plus is on the top for the self-inductance, here it will be bottom. And what will be the value?
J 2.4 I2.
J 2.4 I2. And here it will be plus on the top and it will be J 2.4 I1. So if you write the KVL equations, so you will be getting 50 angle 0. So okay, anyone, what will be the equation? 50 angle 0 degrees minus or plus?
What to find here, sir?
We have to find I1 and I2. So again, we are writing KCL, sorry, KCL and KVL. So what will be the two equations? 50 angle 0 minus
minus J9 I1 plus J 2.4 I2 equal to 0.
okay, and the other equation?
Plus J 2.4 I1 minus J 4 I2 equal to 0.
Okay, so this from this I can calculate I2 to be 0.6 I1, and this is my equation 2. So now substitute this equation 1, sorry, equation 2 in equation 1 and solve for I1. So if you solve, you will get I1 something like this. I1 is nothing but 6.613 angle minus 90 degrees ampere. And then if you calculate I2, 0.6 of that, so it will be 3.968 angle minus 90 degrees ampere. So just check whether you are getting this expression or not, these two. If you calculate I1, then I2 is just 0.6 of that. Anyone calculated I1, I2?
Five 5.89, sir.
It could be 6.613, just check. Same, sir. So Gyanendra is saying same. Just check your math. It will be same. So let us move forward. So I1 we are getting 6.6. So it is also in the range, and I2 is around 3.9. It is also in the range. So now they are asking impedance seen by the source. Impedance seen by the source is nothing but voltage of the source by current it is supplying. So impedance seen is 50 angle 0 by I1. So impedance seen. So impedance seen Z is nothing but V by V1 by I1. So V1 is what? 50 angle 0 degrees by 6.613 angle minus 90 degrees. So the Z that you will be getting is 7.56 angle 90 degrees ohm, because it is impedance, unit is ohm. Just check anyone. The math part I'm skipping, but you should understand the like the concept of the question, how we are getting the equation with the polarity of the voltage sources, and from there how we are getting the equation. From there it is just a math.
Same
So
answer. Same answer.
same answer, right? Okay. Yeah. So yeah, like that's all for today, as we are approaching 8 o'clock. We have discussed about self-inductance and mutual inductance today. So we have started with the dot polarity, and then we have seen how the dot convention will affect the polarity and what are the two cases. And then using those two cases, we have solved 4 problems today. So the method is, first you have to identify under which case it falls, then write the polarity of the voltage sources, apply KVL, and then solve for the unknowns. Yes, so I think everyone is very interactive today. Yeah, the session was good. So from my side also, it will be I feel good if you are more interactive. So any
Please
queries you
show
have?
the, yes, sir. Please show the problem, sir.
This one.
What they are asked, sir, for this diagram?
So we are they're asking I1 and they're asking I2 and they have asked K and they have asked what is the impedance seen by the source. Impedance seen by the source means how much current it is supplying net. So if I am replacing this entire thing by some impedance, what is that impedance? So the voltage by the current is that impedance. So we have calculated V1 by I1, which is that impedance.
Previous problem, sir.
Okay, so there is less than a minute. If this meeting ends, kindly join. So in this question, they're asking what is I1, what is I2, what is I3, what is V2, what is V3. So which I have calculated and then kept so that you can also cross check later. Gyanendra is saying thank you so much for helpful session. Yeah, thank you, Gyanendra.
Impedance is given in the
So if this meeting ends, please join back as we are continuing our discussion. Yeah, sorry, I could not follow what you were saying.
impedance is given in the lesson.
Sorry, your voice is totally breaking. If this meeting ends, please join back.
Impedance is given in question itself, Nasser.
No, they have not given
Z1.
impedance. No? They're
That
asking
is,
what is the impedance. Not this impedance.
they
This
have
entire
given
thing has to be.
question of the J9. Here impedance is given in question, Nasser. Then
Okay,
why
okay.
have we have to find?
Yes. So basically, whenever they are saying impedance seen by the source, so basically they are meaning they have to replace this entire thing. So the problem will become something like this. So we are replacing it by net impedance Z, and this is the voltage source. And say this is my V, and this is my I1. So this basically they're asking Z. So the entire circuit is replaced by Z. So now you know that now you know that Z is nothing but V1 by I1 because Z is not just an inductance, it is the entire circuit that we are modifying, right? So the entire circuit is simplified like this. So the voltage source is seeing an impedance Z, which can be calculated by V1 by I1. Now, is it
So,
clear?
but practically we can write Z1 is equal V1 by I1 for that circuit, not J9.
So if you are saying that, will that hold good in this circuit? Like V1 equal to J9 into
Yes,
I1.
sir.
There is some mutual inductance term also, right? Got it?
Okay, sir.
Because it is
If
mutually
there is
coupled, it is
no
not. If it is only pure
inductance,
inductor, yes, then you are right.
okay, sir.
Any other queries? Others?
Only they have asked to find Z1, sir.
Yes, only
But
they have
if they
asked.
said,
Yes.
okay, sir. Thank you, sir.
It was nice session, nice interacting with you. Any other
Thank you,
queries?
sir. No, sir. Thank you, sir.
Okay. Okay, then if you don't have any queries, then we can end this session today. It was a great session. All of you were very interactive and I hope this session was helpful to you. I wish you all the best for your assignment file and see you again with week 6 on the next Monday, 6 to 8 p.m. Good night, everyone. And I wish you all the best. Yeah, thank you. Thank you, Nandini. Okay, then I'm ending this session here.